Today we will do some revision class. We'll do one revision class on the previous chapter, that is called motion. So we'll go on overview. So first one, we have to know that what is rest. So chapter name was motion. So what is rest in physics? The rest and motion are two different states of an object. So an object is said to be in the state of rest if it does not change its position with the time with respect to its surroundings. So if I keep the pen here, and if I found the next morning this pen is still in this position, then I can say that the pen was at rest condition. Okay, and then or if I found the next day it's come to here, then what I can say, that the pen is in motion. Or if I leave this one, sometime it is going like this way, so this is in motion. Okay, so in physics the rest and motion are two different states of the object. So an object is said to be in rest if it does not change its position with respect to time and with respect to the surroundings. With time and surroundings, if it is not changed, it will be at a rest condition. So now next one is motion. So motion also, you know this one, an object is said to be in the state of motion if it changes its position with time and does not remain stationary with respect to the surroundings. Surroundings means what? Surroundings means the outside things. Okay, these are known as the surroundings. Now the state of rest and the state of motions are two relative terms. Okay, so that means what? That means you have to suppose you are sitting in a running train with some co-passengers, and you are not feeling any kind of vibration in the train. Your train is moving very smooth. So when you are talking with your co-passenger, you think that co-passenger is sitting in a rest condition. Okay, but actually you are moving with that person. Suppose if somebody see you from the outside of the train or in the platform, somebody is standing in the platform and observing you, then that person will observe that you are in a motion condition. You are in a motion. Okay, so that is why the rest and motions are completely relative things. Even see, the earth is also not at rest condition. Earth is also moving around the sun, but what we are thinking, sitting in the room, you see that the pen is at rest condition. That means what? We are measuring with our point of reference. Means point of reference means from where we are measuring that thing, from where we are observing the thing. That is known as the point of reference. Suppose I am standing in this position, and observing this pen. Okay, then what I'll see tomorrow itself it is rest. But actually what's happened? Actually the earth is moving. So entire thing, me and these objects also moving in the space. So that is why that is also in not rest conditions. And remember, in this world nothing is in the rest condition. Everything is moving. Whatever the things which you observe, all are relative things. Okay, so that is why it is called the state of rest and the state of motion are two relative terms. And next one is the reference point. Remember this one, reference point, very important term I used. Reference point is need to describe the position of the object. A reference point used to describe the position of the object and can be the origin. Okay, that means the train was moving. If the reference point is inside the train, then obviously you will see all the passengers inside the train. From that reference point, they are in rest. So if I observed you, suppose in case of in this position, suppose if I take the reference point, this one, I am observing this pen. So what I'll see, the pen is at rest condition. Now if this reference points will go to outside of the space, then what I'll see, this pen is in moving condition. Okay, so if it change the observation point, that observation point is known as the reference point. Okay, so now next one we'll go to distance and displacement. Distance and displacement. So distance, already you know, distance is the total path covered, is known as the distance, and displacement is the shortest distance between the initial and final position. Suppose there are 2 points, A points and B points are there. Now distance means you can come from A to, you can start from A, you can go to B in the several ways. You can go in this way, you can go in this way, not about the things, not about the path you like, you can go. The path you covered, this one, that is called the distance. But in case of displacement, you have to go to straight in this direction, straight in this path, like this way. Okay, that means the shortest distance between A and B is known as the displacement. So displacement path will be only one, but the distance path could be anything. Okay, the shortest distance between the final initial position is initial position, this is called the final position. The shortest distance between initial and final position is known as the displacement. Okay, and the total path covered, okay, is known as the distance. So distance is a scalar quantity and the displacement is a vector quantity. So this thing already we know. Now we'll discuss about the difference between the distance and the displacement. So when the question comes, write the distance, the difference between the distance and displacement. Like this way you have to draw distance and displacement. So what is distance? Distance is the total path length covered by an object during a given time. Okay, it is the total path length covered by an object during a given time is known as the distance. And what is the displacement? Displacement is the shortest distance from initial position to the final position of the object during given time. That is the displacement. Next one you will write, it has a magnitude only, no direction. So I told you there is a magnitude but no direction, you can take any direction. It has a magnitude and no direction, thus the distance is a scalar quantity. It's a very, very important point, you have to mention this one. And in case of displacement, how do you write? It has a magnitude as well as the directions. Okay, because you have to, if you shortest distance between A and B, you have to go towards B. This is the shortest distance between A and B. Okay, so it has a magnitude as well as direction. Thus the displacement is a vector quantity. Okay, and third point you will write, distance is always taken as positive. Okay, and then displacement is, it is positive, negative, or even zero. Suppose if I'm going from A to B, if I take this one as positive, now will come from B to A will be taken as negative. Okay, then if you go from, if you start from A, you go towards B, then you come back from B to A, then your initial and final position will be the same point, then your displacement will be zero. Okay, so that is why the displacement could be positive, negative, or even like even zero. Okay, so that is the thing. So third point, this one. Fourth point is, the magnitude of distance can never be less than that of displacement. So the magnitude of the distance can be equal to displacement, but can never be less than the, because displacement is the shortest distance. Less than that it is not possible. Okay, so that is why it is said that the magnitude of distance can never be less than that of the displacement. And in case of displacement, you have to write, this is the fourth point I told you. In case of displacement, you have to write that the magnitude of displacement is either equal or less than that of the distance covered during the same time. Okay, so what I told you, the magnitude of displacement is either equal to or less than that of distance covered during the same time. So these are the 4 points. You have to remember this one to understand the distance and displacement clearly. Okay, now we'll go one small, very easy numerical. So I write down the numerical here. So you started from A position. I'll use a different color. Draw the diagram. Very simple thing. We'll start it from A position, then we'll go to B position in this way. Suppose you distance travel 1 kilometer. Then this is B position. Then B position to C position like this way. Then distance travel is 1 kilometer again. Then from C position to D position is also 1 kilometer. And then from D to E position, D to E position, and then from E to F position, and then from here, from the G position. They're all 1 kilometer, 1 kilometer, 1 kilometer. Okay. So we need to be 1 kilometer, B to C 1 kilometer, C to D 1 kilometer, D to E 1 kilometer, and E to F 1 kilometer, and also F to G 1 kilometer. Now from here to here, this one remain 3 kilometers given, 3 kilometers. So these are the things given. The picture is given. Now you have to find out what is the distance, or is given here. What is the total path? So remember, total path length covered by her. Okay. So the total path length covered is called the distance. So solution, total path covered. How much you can add this one? So AB plus, right, AB plus BC plus CD plus D plus EF plus FG. Then you can write 1 plus 1 plus 1, 1 plus 1 plus 1 plus 1, like all the ones. So 1, 2, 3, 6. 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 6 kilometer. So 6 kilometer. Total distance traveled is 6 kilometer. Okay. So now what is the displacement? Shortest distance between this AG is the distance, it is A point. I forgot to write this one. It's AG point. Okay. So AG is equal how much given? 3 kilometers. So 3 kilometers. Remember that distance is always more than the displacement. Also, you can remember one term, that distance with direction. The distance with direction is known as displacement. Okay, that also you can say. So displacement is less than the distance covered by her that we have shown. And already I told you the difference between the distance and displacement. So next class we'll continue with the velocity and speed and velocity. Okay. So thank you very much.